Okay, pH. What does it mean? Anytime you have an acid, let's take hydrochloric acid, for example. It's just HCl, basic strong acid, mineral acid. When you add this to water, it reacts the same way the this hydrogen comes off as a positive, the chlorine is a negative. So we have the negatively charged chlorine. Now the water is H3O plus. The water absorbs that hydrogen. Remember on the last sheet how I showed you the water is H2O. Well, this oxygen has two unbonded electron pairs. That's negative. So in an acid, that can attract another hydrogen and become H3O plus. And that's what happens in this situation. The same way as a base. When you're talking about a base, the water loses one of those hydrogens and becomes an OH minus. This is the base. Anytime you hear a base, unless you're talking about an organic base, that usually means nitrogen. A base is an OH negative. It's a water that's lost a hydrogen ion. An acid is H3O plus. It's water that's gained a hydrogen ion. This right here is what we call dissociation when it's involved in acid or base. The hydrogen dissociates from the parent molecule. This could be an alkaloid, an organic acid. Remember the last video we was talking about acetic acid, this molecule. When it dissociates, it's the same thing. The hydrogen leaves and you're left with an O minus and then an H3O plus, which carries the positive charge. This dissociation, in this situation, every molecule will lose this hydrogen. This is what's called a strong acid. Mineral acids are. Organic acids, however, when you mix this with water, not all of them is going to lose this hydrogen, only a small amount. The rest stay in this form. Of course, that's also pH dependent. Well, I'm talking about just pure thing. The rate or ratio of how many dissociate versus how many that don't, that's known as the dissociation constant, Ka. The reason I'm going through these equations, when you look up, like if you look up DMT, N-dimethyltryptamine, if you look that up on a website, they're going to give you solubilities, and you're going to see things like this. You're going to see sometimes a Ka value. The most important is the pKa value. The Ka is the dissociation here. It's just simply a ratio. These brackets mean concentration. It's the ratio of how many come apart like this. I'm just going to write a shorthand. A stands for acid. The concentration that come apart divided by the concentration of acid that keeps the hydrogen on it. So a high value of Ka, like if you see a Ka in 50, 100, 200 that's high, that means the amount that dissociates divided by the amount that don't is very high. So you're going to have a lot that dissociate and very little that stay in the acid form, in the uncharged form. A low Ka value is the opposite. That means very little come apart. Most of them stay in this form. Now the pKa is the value that you're going to see on websites and stuff when you look up values. The pKa is simply the log scale of the Ka value. Now log scale, of course, remember, is multiples of 10. Like the pH scale is also a log scale. pH goes from 1 to 14. 7 is neutral. 6, 5, that's more and more acidic. 8, 9, 10, that's more and more basic. Now 6 is 10 times more acidic than 7 because it's a log scale. 5 is 10 times more acidic than 6. So if you've got a pH of 4, that's 5. That's 3 away from 7. So that's 3 times 10, or 3 magnitudes. That's 1,000 times more acidic than neutral. So like a pH of 1, that's very, very, very acidic. Now, when you look up DMT or any other alkaloids, you're going to see a pKa value. This pKa value is what you want to use when you're going to do an extraction. The reason I'm explaining all this is because this is a value that you can look up. It's a physical property. Say the pKa of what you're wanting to extract is 8.9, for example. Now, that equation I showed you, pH is equal to pKa minus the log of the ratio of concentrations. Using this equation, you don't really have to worry about the algebra to rearrange it back and forth. What you need to remember is if the pKa of what you're wanting to extract is 8.9, according to this equation, if the pH is the same as the pKa value, say you've mixed the pH to be 8.9. At that point, with this equation, this ratio of the acid that dissociates to the acid that does not, it's going to be equal. Say you've got 50 that separate and 50 that don't. 50 divided by 50 is 1. The log of 1 is 0. So that cancels out, it's 0, and you're left with pH equals pKa. So when the pH is equal to the pKa, half of the molecules have dissociated into the charged form, and half have stayed undissociated in the free base form. So when the pH equals the pKa, the ratio is equal. Now, when you raise, let's say you make the pH 9.9, that's 1 point above the pKa. What happens at that point, if you rearrange this, you got 9.9 for your pH. It's 9.9. The pKa of the molecule is 8.9. What is the ratio at this pH? Okay, 8.9, let's subtract that across, cancel it out. That leaves 1 is equal to the negative log of the ratio. Now, for this to be 1, this value in here is going to be 10. That's just, you can punch this in on a calculator, but that's the way you solve it. So when the pH is 1 point above, everything's powers of 10. 1 point above, this is 10. So whatever the dissociated amount is 10 times larger than what hasn't dissociated. With the pH of 2 higher, say we take the pH to 10.9. Now it's 2 higher. That's 2 magnitudes of 10. At this point, it's 100 times more dissociated versus what hasn't dissociated. Now the point of all of this is, when you're trying to pull the molecule out of the water and purify it with a solvent, you look up the pKa. Whatever the pKa is, you need to make it the pH of your solution at least a minimum of 2 points higher than the pKa value. At this point, there will be, as you can see here with this equation, when the pH is 2 points higher than the pKa of the molecule, there will be 100 times more that's not dissociated in the free base form. So for every 100 molecules of what you're trying to extract, 99 of them will now go into your organic solvent for you to pull it from the water phase. This will make a little more sense when you actually see the extraction, but this is just some background to get us started. Anytime you're doing a free base extraction, look up the pKa value. You need to make the pH a minimum of 2 points higher than the pKa value in order to successfully pull the alkaloid that you're after. That's very important. If you remember anything, remember that statement. This that I'm showing you here is the actual why you need to make it 2 points higher. I wanted to go through it just for you that actually wanted to know the background. I hate videos that give a reason for something and don't tell why. I can't stand that. I could have simply said, make sure the pH is 2 points higher than the pKa. Why? Well, I didn't explain that. So if you don't care, I'm sorry, wasted your time. But if you do, there's a little bit more about it. I'll go into a little bit more detail on this too in the actual extraction. But that's all for now. This is another reason why you might want to get a pH meter when you're doing extractions. How you get the pH that you want. Say you boil the stuff, you mix it in, you throw in some acid, you boil it, you pull the alkaloid into the water phase. Now you're ready to extract it with a solvent. Okay, you need to add a base to bring the pH up. How much base do you add? Well, if you don't know the pH to begin with, then you don't know how much base to add. You can say, you can just say, oh, well, I'll just throw in a bunch just to make sure. That's a bad idea. Chemistry is not something you want to guess at. In some situations, guessing is enough. Most of the time, accuracy is what makes the difference in you getting a 20% yield from your extraction and you getting a 96% yield from your extraction. Calculations, pH, temperature, pressure, the right solvent. There's so many variables that actually matter when you're doing something like this. And this is simple. When you get to actually creating molecules, doing synthesis, it's really complicated. And chemistry's never 100%, even when you know all of this stuff. I've studied it my whole life. And sometimes you'll go in the lab, you know what you're doing, you set something up, you do it just like it's supposed to be done, and it just doesn't work. But this will give you the basics. I hope you guys got something out of this. Like I said again, I'm really sorry. I know this is very crude how I'm having to film it. I just not in the best shape financially right now. I had to quit my career job, chemical engineer, to move back home, which is a very small town. There's no work here. My wife, ex-wife now, just randomly left, moved back home. That's another story in itself. But long story short, she'd come across the state line to come back, which is supposed to be illegal, but no one cares when it's the wife leaving. Usually they're favored. So in order to keep my kids, it was over 400 miles away. I couldn't come home every weekend. I was having to go to court. It just wouldn't work. And it was either keep my job or keep my kids. I chose my kids. So I quit my job. I moved back here. Now I've got custody. All that stuff's worked out, but I'm broke. There's no work here. It's a small town. I own my place. Luckily it's paid for, but it's an old house. I've done construction and stuff. I don't have the money to move right now to get another job with my degree. I say it's a small town. If I get anything like that, I'm going to have to move. Moving costs a lot of money, and I'm just kind of stuck right now. But I hope you guys like these videos. Like I say, I was going to make one on medicine. It'll still be coming out soon. But I noticed a couple people in the comments was interested in this DMT extraction, so I'll go into it. Hopefully in a day or two, I'll have the video up of the actual extraction. Right now, I'm just trying to do a little background. And please, leave in the comments if you do like this kind of stuff. I'll try to set up, a little better setup than actually filming me writing it on paper. I know that's kind of hard to follow along with and watch. If you want any details of any other parts, if there's a part you didn't understand very well, or you want me to go over better or in more depth, anything like that, whatever you want. If there's anything in here that you want to explore more, or something that I haven't done yet after the videos, by all means, please leave a comment, give me some feedback. Yes, no, you like it, the sound ain't good, the light's not good, you wish I would have went in more detail, I went too far, just let me know. This channel is going to be for my audience. It's not for me. I'm a nobody on YouTube. I would just assume keep it that way. I'm not here for reputation. I'm not here to be popular. I'm here to try to bring some truth and some actual factual content, because that's getting hard to find. Anyway, you guys have a great day. I'll see you again in the next video. Thank you for watching.